In this video, we are going to talk about extrema on an interval. Extrema means minima or maxima. Okay, if a function has minimum or maximum value in an interval, we call the function has extremum value in that interval. Okay, so extrema also called maxima or minima or maximum or minimum. That's what we call. Okay. So let us look at this graph. The function is defined everywhere, meaning that there is no a point that the function is not defined, right? There is no hole there. You see that? The function is defined everywhere between 1 and 11, closed, because you see the bold, the closed circle on the endpoints, meaning that we use the close or the brackets there, right? So the function is defined everywhere between 1 and 11. So what do you mean by local maxima or local minima? Or in other words, we call relative max or relative minimum, okay? So relative or local max or local min means if a function takes bigger value close to a point in the neighborhood of the point. For example, at 2, you see that the function is minimum, right? And around 2, the function are bigger than that, or the height are bigger than that. So at 2, the height is -2, right? So it is minimum. And around 2, it is bigger than -2, meaning that it is the local mean. You see that? Similarly, at 5, you see that at 5, it takes the highest point in the neighborhood, in the proximity of 5. The height at the 5 is the highest around the points here, right? At 7, it is the lowest around 7. You see that? The height at the 7 is the smallest height that at the points close to 7. So similarly, this is the highest point and that one is the highest point too. But the thing is, at 2 or 5 or 7, you see the combination of decreasing and then increasing and then decreasing and decreasing and then increasing, like that. But at the boundary, you don't see that combination. You have just decreasing and there is nothing on the left side. There is just increasing and there is nothing on the right side. That's the difference, right? Okay, let's talk about the local or relative maximum or minimum. For local maximum or minimum, what we need is the combination of decreasing and increasing, that is the local mean or relative mean. If there is an increasing and decreasing combination, that is the local max. Here it is local mean. Local means only in the surrounding points. You see that? The local means only in the surrounding point. Global means the global max means the highest of all these. And global mean means the lowest of all these. You see that? But for the local or for the global, we also call absolute. Absolute max or absolute mean means global max or global mean. Relative max or relative mean means local max or local mean. Again, local max or local mean is observed only around a point. Okay. Global max or global mean are observed at all the points in that interval. Okay, let us see that. In above graph, fx has a local max at x equals to what point has local max? This is one point, right? At x equals to 5 only. Because other points, this one is not local. Why it is not local? Because we don't know what is happening on the right side of 11. The function is terminated at 11, right? We don't know what is at right side of 11. At 5, we know that on the left of 5, the height is smaller than that value, that height. And then in the right of that 5, the heights are shorter than that height at 5. So it is the maximum of the surrounding points of 5, right? So it is in the neighborhood of 5, in the left of 5 and the right of 5, the height at the 5 is the maximum. That's why it is called local maximum. It is the maximum locally. It is the minimum locally. It is the minimum locally. You see that? But at this point and that point, you cannot say locally because we don't know the other side. That is the reason why we cannot say locally. And what is the local? So fx has local max at x equals to 5, and the local max at x equals to 5 oh sorry, local, I'm sorry. So fx has local max at x equals to 5 and local mean at x equals to 2, at x equals to 2 and then 7. You see that? Because at 2 the height is minimum in the surrounding points, for the surrounding points. At 7 the height is minimum at the surrounding points, for the surrounding points, right? And what is the local max values? So local max value means at x equals to 5, what is the height? It is 3, right? It is 3. So the value is 3, the local max value at x equals to 5. So it is maximum at x equals to 5, but the value, the maximum value is basically the height. The maximum value is basically 3. You see that? That height is 3. And the local mean values, what are the local mean values? At 2 it has local mean, and the value, local mean value is at 2 it is -2, and at 7 it is 1.5 almost, because at 7 you see that the height is 1.5, right? At 7 it is 1.5. The value or the minimum value are -2 and 1.5. You see that? Okay. Note number 2, for local max or local mean, we do not look at the boundary. We do not check at the boundary. Why is that? Because we will see only the left side or the right side of the boundary only, because we cannot say what is happening on the other side of the boundary. That's why for the local max or local mean, because if you want to check at the local max here, because we don't know what is happening at those points, so you cannot check in the surrounding points. So we don't check at the boundary points or the end points of the interval. Because for local max or local mean, we need, for the local max you need increasing, this is increasing and then decreasing pattern, increasing and then decreasing pattern shape for the local max, and then decreasing and then increasing shape for the local mean. That's what we need for the local max and the local mean. You understand? Okay. So for the global extrema, the global extrema may fall at the boundary. You check at the boundary and the local max and local mean, or may fall at the boundary or inside an interval. Okay, because for the global max or the absolute max or mean, you look at where the height is the lowest and where the height is the highest. Okay, let us see that example. fx has absolute maximum at x equals to 11, right? Because this is the highest point. At 11 fx has absolute max or the global max, and the absolute value or the maximum value at that point is basically, it looks like 5, right? It is 5. We look at the y value or the height for the value. Okay, fx has absolute minimum. What is the lowest point? This is that, right? So absolute mean may exist at local mean. So x equals to 2 and the minimum value is -2, because the minimum height is -2 there. You see that? Let us look at this example next. So see, the function is defined everywhere in the semi-open interval, meaning that it is like, let's say this is 1, 2, 3, 4, right, and then 5. You can say that function is defined everywhere between 1 and 5, right? See, I use the open interval and then closed interval there. Open to the left because of the open circle, and closed to the right, bracket on the right because of the closed circle. Now local max, let's find out local max. Where are the local max there? For the local max you need like a cap shape, right? Cap shape. And for the local mean you need the cop shape. Okay, see, the function has local max at 4. You see that? At 4, at x equals to 4. Local max at x equals to 4. What is the value? Value means the height, right? So it is, the value is 2. And is there any other local max? No. How about the local mean? The identity has local mean at 2, right? Because it has a minimum value there. Around the point 2, the lowest height is at the 2, right? So minimum at local mean at x equals to 2, and then the height or the minimum value is -1. How about the global max and global mean? Looks like the global mean is at 5, right? X equals to 5, because for the global you look at the boundary as well. And what is the value? Value is -2. right? How about the global max? What is the highest point? It looks like the highest point is right here, right? But at the left boundary, the function is not defined because there is an open circle. And the highest point looks like this, but we don't know what is that value, right? So max, the global max does not exist, because at the left endpoint, the function is not defined. You see that? So we don't know what is the global max, because you cannot say this is the global max because this is just the local max, but there are some values higher than this, there are some heights taller than that too, right? Because there are many of them. But which one is the tallest, we don't know. Because 3 is not the tallest, because 3 is not defined, it is an open circle. But close to 3, maybe 2.9 is the tallest, you cannot say, because 2.99 may be taller than 2.9, right? And then do you think 2.99 is the tallest? No, because 2.999 may be taller. So we cannot figure out which one is that. That's why we say it does not exist. You understand? Okay, let us define a term. It is called critical number. Okay, so what do we mean by critical number? Is let f is defined at x equals to c. Suppose a function is defined at a point x equals to c. Okay, if the first derivative of the function at c is 0, what do you mean by that? When the derivative is 0, if the tangent is parallel to x-axis, right? If the slope is 0. Slope is 0 means, for example, in this case, the tangent is parallel to x-axis, right? In this case, the tangent is parallel to x-axis. So if f prime of c, if the derivative is 0 or fx is not differentiable at x equals to c. Look at this. Fx is not differentiable at x equals to 3. Why? Because there is a sharp corner. The function is continuous at x equals to 3 because there is no break, but it is not differentiable. If a function has sharp corner at a point, then it is not differentiable at that point. Okay, see this example where a graph is given. Okay, the function is defined from -1 through 7. It is defined everywhere, right? But the function is not continuous. You see that at 6 there is a hole in it, but the function is defined differently. It is removable discontinuity, right? Because the left limit and the right limit exist, but the function value is different, so we can remove it and make it continuous. But the question is not whether it is a removable discontinuity or not. We want to find out the critical points, local max, local mean, and so on here. Okay, so let us start. What are the critical numbers? Critical numbers are the one where either the slope is 0 or the function doesn't have derivative, or the derivative does not exist, right? What are the points where the slope are 0? So -2 and +1, that are the slope 0. So x equals -2, x equals to, let me use different color, x equals to -2 and +1. Also, the function, the derivative does not exist at 3 because there is a sharp corner, right? And then so it is 3. And then at 6, the derivative does not exist. Why? Because the function is not continuous. If a function is not continuous, then the derivative does not exist at that point, right? So 6 as well. Okay, what is the local max and local mean? So let's find out the max. Local max at x equals to max is, this is the local max because at around 1, at 1 is the highest point. The height of the function is the maximum at 1 when you compare to the points around 1. So this is 1, and at 6 as well, right? At 6 it has local max because at 6 the height is like a 5, right? 5 here, the height is 5, and around 6 the height is basically smaller than 6, right? Smaller than 5. So what you do is you will write x equals to 1 and 6, and local mean will be x equals to -2 because at -2 it is the lowest height, and at 3 it is the lowest height, right? Okay, and how about the global max and global mean? Global max is the one that has the highest of those. So it is at x equals to 6, the global max, that is the max, right? And it looks like this is the smallest one, right? At x equals to 3, x equals to 3 is the global mean. Okay, so from here you can see that a function can have local max or local mean, or global max or global mean, even though the function is not continuous at that point, but the function must be defined though. Okay, the function must be defined. For example, if that point was not there, then you cannot say that what is the value of function at 6. You cannot say whether that is bigger than the surrounding points or height at the surrounding points or smaller. Since it is defined everywhere, then we can have local max or local mean there. Okay guys, so at 6 there is a global max and global mean. At 3 it has a global at 6 there is a global max and local max. At 3 there is a global mean and local mean as well. So let us summarize this. So if fx has local max or local mean at x equals to c, then c must be a critical point, okay? Because the local max or local mean can exist at a point where the derivative is 0 or the derivative is not defined, okay? So meaning that if there is a local max or local mean at x equals to c, then c is a critical point or a critical number. In other words, local max or local mean always occur at critical numbers, okay? But if there is a critical number, there may or may not be local max or local mean. The converse is not always true. But if there is a local max and local mean, it must be always at the critical point of a function, okay? So how do I find out absolute or global max or global mean in an not open, closed interval, okay? In a closed interval. So if you are trying to find out a global max or global mean in a closed interval, how do I find out that? These are the steps. Number 1, find the critical numbers. How do I find the critical numbers? Find f prime of x and then see where f prime of x is 0 or undefined. What we do is you find out f prime of x and set that equals to 0, and then you will see where it is 0 or undefined. And those are the critical numbers. Find fx at each critical numbers and at the endpoints, okay? So you plug in those critical number on fx in the question, and then also plug in the endpoints on the question, and then you will see which one is the mix. The minimum one, the smallest one is the minimum, and the biggest one is the maximum. And again, the function must be defined in the interval for local max or local mean, okay? Otherwise you cannot say for sure, okay? Let us look at this example. Find the critical numbers for fx equals to 2x cubed minus 6x on the interval 0 to 3. You want to find out the critical numbers for this, okay? So how do I find out that? Let's do. Solution is to find out the critical numbers, you find out f prime of x first. What is f prime of x? It is 2 times 3x squared minus 6 times 1. The derivative of x cubed is 3x squared minus derivative of 6x is 1, so 6 times 1. So that is by basically how do you get 6x squared minus 6, right? For critical values, for critical numbers, what you do f prime of x must be either 0 or undefined, okay? Since there is no x value that is not defined, so what we do is you just say that equals to, if there is x in the denominator, then you would say what values of x will give this function undefined, right? But there is no x in the denominator, so we don't have to worry about that. So you do 6x squared minus 6 equals to 0. Add 6 on both sides, okay? 6x squared equals to 6, right? Because you cancel that. So divide by 6, you get x squared equals to 1. So what is the x value? X will be plus minus 1. But the interval given here is between 0 to 3 only. So what is the answer then? So answer must be x equals to 1 only, because x equals to negative 1 is outside this interval, outside the given interval, okay? That's why we pick just 1. Otherwise, it would be plus minus 1. Okay, next example. Find the critical numbers of fx equals to x and the root under 4 minus x. That's what you want to do. So how do I find out that is, so so to do that, you find out f prime of x. So how do I find out the f prime of x? It is just the product rule, right? F times g. So it is like, you can write derivative of f. What is the formula? F prime times g plus f times g prime, right? So f prime is 1 times g is root under 4 minus x. You see that? and then plus, right? Plus, what do you get? Plus f times g prime. What is the derivative of root under 4 minus x? How do you find out that derivative? It is similar to 4 minus x to the 1/2, right? It is like u to the 1/2. You can think this as u, basically. You can think this as u. So u to the 1/2. So what is the formula for that? U to the 1/2. It is n u is 4 minus x times to the 1 n minus 1 1/2 minus 1 times the derivative of u, right? -1, because the derivative of 4 minus x is 0 minus 1. Okay, so if you simplify this, what do you get? Root under 4 minus x times 1 is root under 4 minus x, plus you see that x over 2 times, what do you write this one? You can add 1 over root 4 minus x, right? And then there is -1 there, -1 times that. Why did I do that? Because the exponent will be -1/2. If you move to the denominator, it will be +1/2, but that is basically root, right? Now, I want to combine these two. What do I get? Do you know how to combine that? You can write this as basically there is 1 in the denominator and then you multiply those two, right? So what you get is basically 2 root under 4 minus x, right? And then do the cross multiplication, right? How do I do that? So it will look like this times that and then this times that, right? So what you get is root under 4 minus x times 2 root under 4 minus x will be 2 and then 4 minus x. You see that? That's what you get. And then plus 1 times x times -1 will be -x. That's what you get. So if you simplify that, what do you get? 8 minus 2x, right? And then minus x, 2x minus x over 2 under root 4 minus x. So we're going to find out the critical numbers. For the critical numbers, this should be either 0 or undefined, right? For what values of x it is undefined? If you set x equals to 4, it will be 0 in the denominator and that will be undefined, right? So x equals to 4 is 1, but you want to take only for x less than 3. So you don't have to worry about x equals to 4. So what you get is basically, let me simplify this one more time. So 8 minus 3x over 2 root under 4 minus x. That's what you get, right? Now, so when does f prime equals to 0? If f prime is 0, the numerator must be equals to 0, right? That is 8 minus 3x equals to 0. If you solve, if you subtract 8 and divide by 3, -3, you will get x equals to 8/3. So 8/3 is 2 point something, which falls less than 3, right? Which is less than 3. So this is the only critical number. Why is that? Because there were 2 basically, but this critical number does not fall in that region. It is not less than 3. It is x equals to 4 will give you 0 in the denominator and non-zero in the numerator. That will give you f prime not defined at x equals to 4 and f prime is 0 at 8/3, x equals to 8/3. Since x equals to 4 is not in that region, so x equals to 8/3 is basically the this is the critical number. Let us do this problem, okay? So on this one again, to find out the critical number, what we do, you find out the first derivative, f prime equals to 2 minus 3 times 2/3 times t to the 2/3 minus 1. You understand the derivative, right? If you simplify that, what do you get? 2 minus 2t to the -1/3, right? If you simplify this, you will get 2 minus 2 over t to the +1/3. 1/3, right? So there is 1 in the denominator. I want to combine that, right? So what do I get? This is equals to 2t to the 1/3 minus 2 divided by t to the 1/3. You see that? So for the critical values, we need to do either f must be. So either f prime must be 0 or f prime must be undefined, right? This is needed for the critical value, right? So as the previous example, so if you do f prime equals to 0, then you do the numerator equals to 0, right? So you get 2t to the 1/3 minus 2 equals to 0, because you can multiply that to the 0, right? So this implies, let me add 2 on both sides. you get 2t to the 1/3 equals to 2, right? Divide by 2. What do you get? You get t to the 1/3 equals to 1. So basically t is 1 critical number. And what is the another critical number? Another critical number is t equals to what value of t makes this undefined? 0, right? Makes f prime undefined. So what is the critical number? Therefore the critical numbers are x equals to, sorry, t equals to so the critical numbers are t equals to 1 and then t equals to 0. These are the critical numbers. Let us look this example, okay? Find the critical numbers. Again, for the critical numbers, you find out the first derivative. So f prime is how much? 2 cosine of x minus, it is like cosine u, right? What is the derivative of cosine u? Negative sine u times the u prime, right? So if you simplify this, you'll get 2 cosine of x plus 4 sine 2x. That's what you get, right? So to find out the critical numbers, you should set that equals to 0 and then see if at which points for what value of x you get the first derivative 0, right? So f prime equals to 0 implies 2 cosine of x plus 4. Do you know the value of sine 2x? It is 2 sine x times cosine of x equals to 0. So can you take out something? 2 cosine of x, take out, right? So what do you get? You will get 1 plus, you get, by the way, this is 2, right? So if you take 2 cosine x out, then you'll get 2 sine x equals to 0, right? So you do either 2 cosine of x equals to 0. So what values of cosine will give you 0? So it is cosine of x equals to 0, right? If you divide both sides by 2, that's what you get. So what values of x will give you for the cosine 0? That is pi over 2, right? And then 3 pi over 2. That's what you will get. You see that? Pi over 2 and then 3 pi over 2. Similarly, you want to find out for this the other factor equals to 1 plus 2 sine x equals to 0. So subtract 1, you get 2 sine x equals to negative 1 and divide by 2. Divide by 2, right? So sine x equals to negative 1/2. So sine is negative in third quadrant and then fourth quadrant, right? For the third quadrant, you should do, because sine 30 degree is 1/2, right? Positive 1/2. So sine pi over 6 is positive 1/2. So to find out the value in the third quadrant, you do pi plus pi over 6. That will be 7 pi over 6 is one value. That is 210 degree. Okay, and then you do 2 pi minus pi over 6. You will get 11 pi over 6. That is for the fourth quadrant. Okay, so the critical values here are x equals to pi over 2, 3 pi over 2, and then 7 pi over 6, and then 11 pi over 6. So these are the critical numbers there. Okay, let us briefly talk about the extreme value theorem. What it says is, if a function f(x) is continuous on a closed interval ab, then f has both minimum and maximum on that interval ab. Meaning, if a function does not have any break, and then if in an interval that contains the boundary, that is the closed interval, then it has both maximum and minimum lies on that interval, right? For example, in this case, you see that the function f(x) has global max. What is the highest point? At b, right? At x equals to b, and global mean at x equals to c. See, this is the lowest point, right? But if the function is not continuous, or if the function is continuous in an open interval, then you cannot guarantee the maximum and minimum, global max and global mean lie in that interval. For example, in this figure, the function is continuous in the open interval ab, right? Here you have a parenthesis. So what is the global mean? Global mean exists at x equals to c, because at x equals c, it has the lowest point. But the global max does not exist here, right? Because it looks like at b, the height is the highest one, right? but b does not fall in that interval, so we cannot say at what point it is picking the highest point, so we say it does not exist. So the global maximum does not exist for this figure. The reason is because it is continuous in open interval. So sometimes if a function is continuous in an open interval, for example, let us look at this one. So if you have this one, let's look at that, and then so suppose this is a and this is b. Okay, then in this case the function is continuous in the open interval a b, right? But it has both global max and global mean, because see, at c it has a global mean and at d it has a global max. So what can we tell about this then? If a function is continuous in the closed interval, then that guarantees both maximum and minimum lies in that interval or on the boundary. But if the function is continuous in open interval, or if the function is not continuous, then we cannot guarantee the global max and global mean lies in that interval or on the boundary. Okay, so this is what it is saying. So but if the function is continuous in the closed interval, we are 100% sure that the global max or global mean lies somewhere in that interval or on the boundary. That's what it says. Okay guys, now let's do this example. Find global max or global mean for this function. So how do we find the global max or global mean? We find out the critical points, and we find the value of the function at critical points and at the boundary, and see which one is the maximum, that is the global max, which one is the minimum, is the global mean. Okay, let's do that. So f prime, oh, this is basically f over g form, right? Do you know the formula? It is f prime times g minus f times g prime over g square, right? So let's do that. F prime is 12x minus times g is x minus 2, and then minus f is 6x square times g prime is 1, right? This is the derivative of x minus 2 is just 1, divided by g square is x minus 2 square. So if you simplify, what do you get? 12x times x is 12x square minus 24x minus 6x square divided by x minus 2 square. You see that? So what do you get? You basically get 12x square minus 6x square is how much? So can you tell me how much is that? Basically this will be 6x square, right? So it will be 6x square and then minus 24x over x minus 2 square. Can you factor out something on the top? Basically, yeah. So if you take 6x out, what is left is x minus 4, right? Divide by x minus 2 square. So what are the critical points? Meaning, what values of x gives the numerator 0 and what values of x gives the denominator 0. That's what you are trying to see. Okay. So if you take the numerator 0, f prime of 0 implies x equals to 0 and x equals to basically 4, right? And in the denominator, if you do f prime equals to undefined, at for what values of x gives you the 0 in the denominator? X equals to 2. So the critical numbers are x equals to 0, 2 and 4. But what is given there is, it is given that you need to look at the critical number only between -2 and 1. So what we can cancel there then? So between -2 and 1, this is outside -2 and 1, this is outside. So only 0, you will take only 0 there, right? So you will consider only at 0. So what we do is we look at the left endpoint, right endpoint, and then critical number. So what we do is we find out the value of the function, the given function at left endpoint. What is the left endpoint? Fx equals to f at -2, right? Because we want to find out the height of the function at left endpoint. So what do you get? You get 6 times -2 square, right? This is what you will get. You will get 6 times -2 square divided by -2 and then -2, right? What do you get? Is basically 6 times 4 over -4, right? That is basically -6. So you get that is -6. Similarly, at the right endpoint, meaning 1. If you plug in 1 there, what do you get? 6 times 1 square is just 6. Over 1 minus 2 is negative. So -6 again. At 1 also you'll get -6. Let me write down that. So it is -6. F at 1 is also -6. And at the critical point is 0 only, right? So plug in 0 there. 6 times 0 square is 0, and then over 0 minus 2 is negative. So 0 over -2 is 0. So which one is the maximum, which one is the minimum? So global max is at x equals to 0, right? Because this is the maximum value of those, right? At x equals to 0, it is the global max, and the value is 0 as well. So global mean at x equals to -2 and +1, and the value is -6. This is how we answer that. So basically, to find out the global max or global mean, the idea is first find the first derivative, set that equals to 0, find the critical numbers. So for the critical numbers, you find out two different ways, right? One is solve the numerator equals to 0, and if there is x in the denominator, solve the denominator equals to 0 and find out the critical number. Okay, if there is a negative exponent, you need to move that to the denominator and then solve the denominator for the critical number, because critical number are those values of x where the function is the first derivative is 0 or first derivative is undefined. And after you do that, you plug in the critical numbers and then all the critical numbers and all the endpoints to the original given function, and then see which one is the maximum and which one is the minimum, and in that way you will find out the global max or global mean. But when you plug in the critical numbers, plug in only those critical numbers that lies in the given interval or the given domain. Okay, let us look at the last example of this section. So does fx has local or global minimum? Look at this. Does it have local minimum? No, right? Because see, it looks like at C it must have a local minimum because it is decreasing and then increasing. So it looks like at C the height is the minimum one if it was continuous. But at C the height is a little bigger, right? So it looks like this point, okay, this point or that point will have the minimum height, but we don't know what that point is. We don't know what that points are basically. Because at C it is that point, and close to C there are points, but we don't know how much are those because they are the open. Right? These are the open there. So the answer is no for this. No local minimum, no global minimum. How about here? Here it is yes, right? Why is that? Because left to C and the right to C, all the heights are bigger than the height at C. This is the height at C. And left at C and right at C, the heights are bigger. Look at this. Right? At C, the height is the smallest one. So local and global mean at x equals to C. But here it is not. Why is that? Because at x equals to C, this is bigger than near the around C. But after that, other points have higher height bigger than that. Okay. So this is no and this is yes. Okay, guys. Thank you very much.